All right, so if I give you an equation, a graph, say this equation, how do you, up to now, what do you typically do to graph that equation? If you don't have your graphing calculator and no graphing utilities, you make a table, right? That's called the point plotting method, okay? So today we're going to make a table. One of the ways that your book, one of the things you'll see in your book is it will say graph the following equation using the point plotting method. Okay, now to really get a good sense of the shape of a particular graph, unless you know what it looks like, you should pick some negative numbers as well as positive. We tend to always start with just the positive numbers, but you know, you're kind of missing half of the graph sometime. And if you're not aware of what the shape is, you should try to plot more than 2 or 3 points, okay? Now, every time we plot a point, that point, for example, let's take a look at this first point that's already done here for you. It says x is 0. So you put 0 in for x. You square 0, you get 0. You subtract 0 from 4 and you get 4. So the point 0, 4 is a point on this graph. There it is. We also say that 0, 4 is a solution. It represents one solution. It's a solution to the equation y equals 4 minus x squared. Why do we call it a solution to that equation? How do you know that something is a solution? It's sort of a basic question, but not all students know how to answer that. Ian? If I plug it into the equation, what's going to be true, Ian? It's not just plugging it in. I can plug any point into an equation. What makes it a solution? What's equal? The left side equals the right side, right? So you plug, as Ian says, you plug the point, the coordinates into the appropriate places. 0 goes in for x, 4 goes in for y. You do whatever it tells you to do on the right side in this case, because this equation is solved for y. And if the left side equals the right side, you're golden. That's a solution. That makes the equation true. Okay, so other language that we use all the time, or at least math teachers use, and I just want to make sure you're aware of this, we say that this is solved, this equation is solved for y, because y is all by itself. It's y equals 4 minus x squared. This equation is also an equation in 2 variables. That's another way we refer to this equation. This is an equation in 2 variables. Okay, whatever we plug in, whatever value of x we plug in, we solve for y. So we call x the independent variable. We're free to roam. I can pick any value for x on the whole number line I want. It's totally independent. There's no like boundaries or rules about what x you pick. But once you pick a y, boom, excuse me, once you pick an x, y is determined. So y depends. It's the dependent variable. Depends on the value of x. Okay, so that's just some language. Now, if this was a story and it had a context to it, there may be other letters other than x and y. The standard in mathematics is when you're using letters from the alphabet, often the letters are in alphabetical order here. X goes before y. Okay. So if we were doing this with the point plotting method, we would go in and we would take each value of x, we would substitute it where we see the value, the x, I'm talking too fast. We would take x equals -3 in this case, and we would substitute it where we see the x. The thing you have to remember is because x is negative, it must be in parentheses, because -3 times -3 is very different. These two things are not the same. Okay, these two things are not the same. So you need to put parentheses around that. So that's 4 take away 9, which is -5, which means your point is -3, -5. So then you go up and you plot that point. You go 3 to the left and down 5, and you put a little dot right there. Okay? So someone want to tell me how to do what the value for y is when x is -2? What is the value for y when x is -2? 0. Do I have consensus? A couple other people? Yes, yes, good. Okay, so x is -2, y is 0. So that means on my graph, I have another solution. There it is, -2, 0. Okay. And how about -1? I put -1 in here. If I hear 3 answers all the same, I'm going to go with it. Oh, 3. Any other 3s? 3, another 3. 3. Okay, -1. -2 times -2 is -2 times -2. -2 times -2. +4. 4 take away 4 is 0. Okay? All right. So any questions, please ask, because we don't want you going home, whoops, confused about something. Okay, so there's our next solution. And then we've already done 0, 4, and then we put 1 in again, and let's see what we get. Oh, we don't put 1 in again. We've put in -1. Let's see what happens when we put in +1. Oh, interesting. Exact same value of y. So at 1, I'm at the same height above the x-axis that I was when I was -1. I'm at y equals 3. So any guesses what the remaining points are here? The opposite of what's above. What part's the opposite? Just the x. So instead of -2, it's +2, but the y value stays the same. And instead of -3, it's +3, but the y value stays the same. So the only part that changed was the value of x became its opposite. But the y values were exactly the same. We had -3 here and -5. We have +3 here, and we're still at -5. We had -1 here and +3, and we have 1 here and +3. We had -2, 0, and +2, 0. What's the only point we don't have sort of a counterpart for, like an opposite of? 4, 0, not 4, 0, 0, 4, because it's right on the y-axis, okay? Does anybody know remember what we called this point right here? I've heard different things. I heard vertex, which is true, but let me hold on to that for a second. Let's finish this first, and then maybe it will be apparent to you. So right now I have 7 solutions to that equation, individual solutions. But that equation has how many solutions? Infinite. So the only way to represent that is by connecting all of these points, and I use an arrow because this is going to go down. There's no boundary on what x's I can put into here, and I come up and I'm going to take a turn at 0, 4, and then I'm going to head back down. Okay. So the graph of this equation, the graph of y equals 4 minus x squared has what type of shape? What parabola is a parabola? And it represents, the graph itself represents the entire solution set for that equation. Any point on that graph, if you could actually get the coordinates, you could plug it back into that equation and your left side would equal the right side. Okay? So let's think of this. We have this graph and it's bumping into the y-axis here at 0, 4. Does that give you any idea or a little memory jog of what that might be called? The graph. What happens when someone gets in the way of a Brady pass? What do we call it when it's not someone from our team? The y-intercept, right? That's called the y-intercept, right? So what do you think these 2 points down here are called? X-intercepts, right? Okay. All right. So at your seats real quick, see if you can use your point plotting prowess to come up with the graph for the absolute value of x. So I've given you 7 values there. See if you can come up with 7 solutions and then connect them all with some kind of continuous line. And once you do that, graph that you just created on your by hand by plotting points. So to do this, you go over to the y equals button. I'm going to clear everything right here. And how do we get the absolute value? Because they don't have that symbol like you're used to doing, the two vertical lines. There's two places, so take whichever one makes the most sense to you. There's a catalog in just like a shopping catalog. It's down here above the zeros. See the word catalog? So if you hit second zero, you have catalog, and there's all these different things you can do. Notice the very first one says ABS. That stands for absolute value. So you could just click right on that. You could hit enter right now, and there's ABS, and we're interested in taking the absolute value of X, so you throw an X in, and you close your parenthesis. You don't have to close the parenthesis. It will be fine. Okay, that's one way to do it. Let me clear it and show you the second way. The second way you can do it, does anybody know the second way? What other way of getting to the absolute value symbol? Yeah, Haley? Math. Right, so if you want to go across this top bar here, you have to use your horizontal cursors. Which one do I go to? Number, N-U-M, and there you go. There's your absolute value again. So you got two ways to get there. Again, you throw an X. You don't have to put the absolute value in. Okay, there it is. All right. Now, whenever you want to graph something, you have to tell the graph what window you want. Sometimes the hardest part of getting graphs on your graphing calculators is putting in the appropriate window. You've got to look at your expression or your equation and say, well, if I put this value of X in, I'm either going to get a really small value of Y or really big. So you've got to adjust your window so you can see your graph. Now, the standard window, and this is all in your lecture notes, looks just like this. It goes from -10 to +10. This is your X minimum. This is your X maximum. And notice what are your increments here? What's the size of your increments? 1, right? So we write that like this. That represents, so my viewing rectangle starts at X -10. It increments by 1 up to +10 by, and now my Y values are exactly the same. They start at -10, go up to +10, and they increment by 1. Okay. Now, if you want that to be any different, you go into your window. We looked at this the other day. You go into window, and you can change it. So if you only are interested in looking at the value, say, from -3 to +3 for your X, but you want really small values, like, say, 0.1, you can do that. You could change it to 0.5 if you want to do that. So you're looking at every half value. And then similarly, you would change your Y scale. In this case, we know it's exactly the same because it's absolute value. You may not know what to change. And then you hit graph and notice how the graph changes. Now, this value out here represents -3, and this is -2.5, and this is -2. It increments by a half unit. Okay, so if you wanted to change your window or your viewing rectangle, you just go into window and you make your changes. Okay, so the viewing rectangle here, I would represent tau. Let's see if you can help me. So the first part of your viewing rectangle, by all your X info goes in the first one, and all your Y info goes in your second one. So how would I fill in the X info box here for my viewing rectangle based on what we just put in? Does anybody remember where we started? The lowest value, -3. Then my highest value was 3, and I incremented by a half, right? Okay, and then Y, same thing, -3, 3.5. So this is called your viewing rectangle. Okay. Any questions on that and how to use your calculator for that? Okay, we actually worked in class the other day on setting the table. So we just plotted points. You all, Ian, Austin just came up and put all the points, and you plotted points. But again, you can use your calculator to do all of that work for you. Your table on your handout started at -3, and you were incrementing by 1. That means you were looking at all your integers. And if we want our table to automatically just give us all the y values, we hit enter here. So it's going to automatically fill in from -3, incrementing by 1 as far as you want it to go. You hit second table, and there you go. And you can just sit here forever and ever and look at all the values, all the integers, and this is just going to go forever and ever, okay? Now, if there's a particular value you want and you want to ask your calculator to do it instead of having it do it automatically, then you go to your table. And do you remember what you changed? If you want your input, your independent variable, to be something you want to tell it to do, instead of just having it be done, you have to hit ask. So you cursor over, you come down here, you cursor over to ask, you hit enter. And now when you go to the table, it's saying, okay, tell me what you want. Isn't that what we always want to hear in life? Someone wants to tell you, you know, says to you, what do you want, right? Oh, $1 million would be good. So here's where you actually put in whatever value you want to put in for X. And once you hit enter, boom, it is calculating whatever is in Y1 in your calculator. It's finding the answer based on what you've put in Y1, which is absolute value. If you had another equation in here like 4 minus x squared, which was our parabola we just looked at, and then you hit second table, notice it gives you 2 columns. It tells you when you put this x value into the absolute value, it comes out looking the same. When you put this x value into 4 minus x squared, this is your y value. So this represents a point on that parabola that we just drew a few minutes ago. Okay, so you can have several different equations in the y equals at the same time. And if you're doing point plotting, this is a quick way to do it. So for homework, when it asks you to plot points, use your tables on your calculators. You know, it will go like that, be really fast. All right, any questions on, yeah, Sam? Error window range, okay. Okay, I'll come over and do that when we have time to start working individually, okay? I can probably fix it for you. It could be something, do you have any data in your lists anywhere? Do you have data entered into lists? Okay. Okay. All right, so I think I've covered everything in today's lecture. Let's see, let's take a quick peek. I didn't do it necessarily in order of the lecture notes. We were graphing 4 minus x squared. I don't have today's lecture notes because I gave it to Ben. Ben, can I look at them real quick? Yep, okay. So we have to talk about, we did talk about how to graph and the window and all that. We can actually go into GeoGebra in a minute, and we're going to have lots of time. The only thing I want to do is show you how to find the x and y intercepts. So let's take a look at that. Any questions right now before we move on? Any questions? Okay. So finding the x and y intercepts of a graph. Okay. So let's see. What did we just have a minute ago? We had, let's take a look at the parabola we just had. So I'm going to shut off the absolute value graph, and I go over to the equal sign, and I just hit enter, and it shuts it off. Okay, so the only graph I want, and I want my standard window, and to get my standard window, I go to zoom. When you want it to go from -10 to 10, you come down here where it says Z standard. So you come down, you can either toggle down, or you could just enter the number 6 and hit standard. And there is my graph 4 minus x squared. So let's get a picture of that up here. Okay. Okay, so we know what we're talking about. So the x and y intercepts. So we said when your graph gets in the way of your y-axis or your vertical axis, it's called the y-intercept. And when your graph gets in the way or runs into the x-axis, it's called the x-intercept. What is always true about one of the coordinates for your x-intercept? What's 0? Think about where you're sitting down here now, Shane, before, okay? What's 0, Shane? Y, okay. All right, so that only leaves for the y-intercept, what coordinate is 0? First one, right, your independent variable. Okay, so if you're trying to find out how to algebraically find the x-intercepts to this equation, not with a graph, but algebraically, then you need to just sort of imagine in your mind. You don't always have to memorize these things. Just say to yourself, when I'm sitting on the x-axis, which one of my coordinates is 0? Oh, yeah, it's not the x, it's the y. Well, sometimes it could be the x as well. But I set y equal to 0, and I solve my equation for x. So I set y equal to 0, and I solve my equation for x. So the first thing, because I've been sort of trying to get you in tune with this idea, as you notice this is a quadratic equation, and unless it's x squared equals 0, you're going to have how many answers? 2. So you should be expecting 2 solutions, which means you should be expecting 2 x-intercepts, okay? So that you don't fall into that evil temptation that when you add x squared to the left side, x squared equals 4. And now when you do your absolute value, excuse me, oh, I was giving away the answer. When you do your square root of each side, we know that that symbol represents the positive or principal square root or the non-negative square root, which is 2 here. But when I write the square root of x squared, what is the answer? Absolute value of x, right. Now to solve that equation, I know there's 2 numbers I can put in for x whose distance from 0 is 2. X could either be a positive 2 or the stuff inside call x could be a negative 2. And that's how you always ensure that you don't forget that it's a plus and minus 2 for your answer. The other way to ensure that is you could have done this, you could have done this. You could have factored your equation, okay? You could have said 2 plus x, 2 minus x. You could have factored it because it's a difference of perfect squares. Set that equal to 0. That's going to equal 0 when x is a negative 2. And set that equal to 0. That's going to equal 0 when x is a positive 2. Okay? So factoring also will give you both answers. Okay? But if you've sort of all along willy-nilly done this sort of thing and did this, you're going to run into trouble because you're losing one of your solutions. The square root of x squared is not x. You only got half the story here. Okay? It's got to be absolute value of x equals 2. Okay, and that's what we covered last week. Was that the first class? I think that was the first class, class 1. So if you're coming into class late or you've just added recently, you want to take a look at the lecture notes for class 1. Okay, graphing calculators, we are now done. Now let's pull out our GeoGebra. Now let me just bring your attention here. There's a couple of ways on your graphing calculator with your trace button that you can find the x-intercepts. Read this on your own. This will be part of your homework tonight. But I want you to have a half an hour to work with GeoGebra. So wait a minute, before you open it, I know I just told you to open it, didn't I? Now I'm going to ask you to hold back for 1 minute. I know it's hard, but I've seen, close your laptops, whatever. I've seen this before when I've sat in. I used to be in administration. I used to have to evaluate teachers. And when I used to go to the computer classes, the teacher would be up there saying, now everybody pay attention. And you got this computer right in front of you, you know. You know that out of a class of 20, there were probably 15 people doing 15 different things, right? So let me just bring up GeoGebra for you. A lot of your, some of your projects that you do, you can do it on GeoGebra. And so Caitlin and I decided, hey, we got a new book this year. We got graphing utilities coming up real quick. Your projects will be using GeoGebra. Let's introduce it with the Chromebooks right in class. So this part over here, you see where it says algebra? It's called your algebra view. So any equations you put in, any points you put in, they're all going to show up over here. This is your graphics view. Right here is this move button. This is like really critical. Once you hit that, you can move this all over the place, okay? It's like your viewing rectangle. Now, I have a hand. On some of your fields on your little Chromebooks, you'll see like a plus symbol, all right? Now, you want to change your scales, say. All you do is you still got the move button on. You bring this little hand over to your y-axis and it turns into a double-headed arrow. You just can squish that scale down as much as you want. Or you can right-click. This is a really good thing. You can right-click and you can go in and you can tell it what the X-min and X-max and Y-min and Y-max is. So if you don't want to take the time to keep, scrolling your axes down, you can right-click. The right-click is a really handy feature in GeoGebra. Same thing here. I can right-click, go to graphics, and let's say I want my X minimum to be 0, and I want my X maximum to be 50. And the minute I do that, it's done after I hit enter. Okay, so I move this out of the way and there's my scale. So I don't have to like squish it. I can tell it how I want it to go. Again, you want to see more of your graph, you just move it around. Okay, how do you input points? Let's go back. Let's pull out now. Yeah, that's right. I just put up the whole thing. I can do this like that. Okay, so take out your group activity for today, and I want everybody to be on the same page. Caitlin brought me all the wrong ones. Okay. So can you just scoot with Lenny for a minute? Do you recognize this data? Yes. It's from class 1, right? I got it now. It's from class 1. We started class off with this, right? This was tuition and fees. How did we define X with this? Do you remember how we defined X? Years since or after 2000, right. So notice on the bar graph, the very first point on the bar graph is 2000 for the X. And what was the cost of tuition and fees? 3,300, I don't have my glasses, $62, okay? So if I want to plot that point, I'm not going to put in 2,000, 3,362. What will I put in? 0, because 2000 is 0 years from 2000. That's my initial point. That's like your y-intercept. So to do that, you don't have to do it right now. I just want you to watch what I'm doing. In the input bar, okay, are you guys watching? In the input bar, you put parentheses, you put 0, 3362. Now when I hit enter, the point appears over here. They've given it the value A. Do you see it on your graph? Why not? Because of the scale. Right? So I just come over here and I keep squishing this down until I get to the 1,000. Oh, there it is. Okay, it's the y-intercept in this case. What's my next point going to be? Right, 2001 is 1 year after 2000, and what's the cost of tuition and fees? 3,487. I hit enter, and there's B. Now, if you want to spread this out a little, just take this axis because you're only going to 10 and spread it out as much as you want. You can even squish this down a little bit further if you want. Okay, it's totally up to you. You can go like that, you can go like that. Okay. All right, so I don't know about you, but when I look at my points, I can see their coordinates over here. Let me show you another little feature of GeoGebra that's really nice. The right clicking is really cool. Right click on a point, right click, go down to object properties, You can change the color of the point, you could change the style, blah, blah, blah. But you see right here where it says label, show label, right now it just says label name. Here's the name, B. I want to see the name and the value. Boom. Okay. I want the name and the value for all of my stuff because when I look at my graph, I want that information, name and value. Okay. So that's how you can actually get that. All right. Now, there is a typo in your lecture notes. So let's fix it right now. There's 3 typos. If you look down to number 3, you have an equation. Does your equation look like my equation? No, because it says 985, doesn't it? So change that to 385. So please change to 385. That's one change. And then in questions 4 and 5, it refers to question 6, right? Please change that to question 3. Make those 2 little changes. Okay, so you're all set to go with your GeoGebra activity, and if you finish that up, there's a graphing calculator activity as well. Okie doke. So let me, if you have individual problems, just let me know and I'll come over.